Hi everyone, welcome back to D4 Data channel podcast on the topic detecting fake point of interest. And with me, we have Mr. Syed Raza. So Syed has been in this particular industry for quite some time, and he is currently pursuing his PhD from Toronto. And he has been studying a lot about detecting fake points of interest in Google Maps and how we can recommend the exact fake-free POEs to the user community. So I'm really glad that Syed is here in this particular podcast. So welcome, Syed.
Thank you. Thank you so much. Thank you.
Yeah. So I have some quite number of questions today for you,
Yeah.
and so starting with this particular question. So first of all, when you started this investigation, like what
Yes.
made you understand, like okay, there have been a lot of fake addresses in Google Maps.
Yeah. So the thing is that I was doing my research papers, in fact, survey on security and privacy. And I wrote that one. It's a very huge survey paper on privacy and security of IoT devices using edge computing and also cloud computing. So when I was doing my research on that one, and that paper will be coming very soon, and it's a very nice and very like it gives you like it's around maybe more than 70 pages. So it's like goes through everything because when you go for privacy, there is identity privacy, there is location privacy, there is address privacy. So there are different types of privacy and also with security as well. So privacy is very important topic over there. So when I was doing that research on that, and I found that one that there are many fake listings that are appear on Google Maps rapidly, and the amount of that enormous. So the amount of like having those fake point of interest is enormous. So the thing is that if you see that report, I also that like my this paper, this fake point of interest locations on Google Map is just published in IEEE 2021 Big Data Conference last month. So that was like my work is already recognized. So that is one thing that is very important. So the thing is that when I was doing that one, and first I looked at one in 2018. So at that point, they also have millions of fake listings. So in 2021 also, so I go through with a statistical report, and that in 2020, Google Maps approximately has 23 million downloads in the United States, and Waze come next. So the amount of people that using that Google Maps and Waze, and you know that Waze is also bought by Google. So the thing is that almost like 34 million downloads in US, and it has like 3 million fake addresses total overall. So the fake addresses are coming up rapidly, and there is a report also that published, and Google admits that one that we remove lot of them, but still they have lot of in place as well because the amount of like the fraudulent data is coming up like very quickly. And also the way that Google basically verifies that one is through calling phone or through sending a letter or something like that, so they can easily do that one very easily. So there is no like very concrete steps that Google makes to verify that one. And these type of like the listings coming up, and like for example, if you have a office in third floor, so you just put the postal code over there and that will be verified, right? And you don't have any office on the third floor. So these type of things coming up, and Google also noticed that one and removed some of them, and like it's a ongoing process. So they are looking for some algorithms that it will be very efficient for that, so that efficiently recognize, and then they can basically use that one. So my basically working is on the recommendation side. But before that, when I was working in privacy, so when I was giving some tourist or some recommendation of point of interest, so first I need to make it sure that the data is fake free. So that now I have like fake free data, and then we can recommend that one. And maybe in Canada it happens, maybe in your place it happens that you see different things, and when you go over there, there is no place over there. So these are the things that is coming up. And Google had already admitted that one, there are different forms over there also, and different blogs, and different, even in Wall Street Journal they published the article on that one as well. And also, the thing is that Google also put, if you go to Google website, they also put a form over there that how to report a fake Google listing. So they are asking people also to give us the report. So these are the things that I confirmed that one, that because from their official website also.
Got it, got it. So there is a significant proof on, like, okay, there
Yes,
is a lot of
even
fake
like
addresses
even
basically.
the company said, the company on their own official website admitting that one.
Got it, got it. Okay, okay. So yeah, like I think you address this in a bit,
Is
like
basically
why?
that is,
What do you
yeah.
think? Like why? Yeah.
So the thing is that they are not
So why
neglecting
like
it,
Google? Yeah.
not neglecting it.
Hmm.
But the thing is that the amount of data, like amount of fake addresses that are coming up on daily basis, there are different ways to like hack the system. Like if you just Google that one, how to have a fake address on Google Map, you can find many tricks, right? So there are different tricks, like having the one postal code, maybe having a phone number, one phone number for 10 companies, things like that. So there are different ways, and you can Google it, you can find it, and you can apply that one, and you can have your point of interest on Google Map. So the amount of thing, the amount is too much, the
Got
data
it.
coverage is too much. That is the reason, and they are doing that one, they are doing on it. But you know that Google is already making a lot of money, so they are addressing that part. But the thing is that the, like if they are 100 million point of interest, maybe 4 million is fake. So it is reported, but the percentage is low, as but the number is very high. So we need to address that one.
Yes. So when we are talking about other services like Google Maps, so have you seen this kind of a behavior in other Google Maps similar kind of services actually?
Yeah, so I see that one, that in OpenStreetMap also they have some issues with that. Like, but the comparison is not very. You can say Google has a enormous data, and OpenStreetMap has a localized kind of a thing. And in map, we usually call it as map vandalism. So the terminology is not fake point of interest, we call it as map vandalism over there. And the OpenStreetMap is kind of a local problem, so they can quickly identify that problem, and then they can remove that one. So because the data is less, the you can say the parameter of the problem is less. So I'm researching on that one also. They said that they removed that fake listing, fake vandalism on map. The terminology is map vandalism. They remove it in like 1 to 2 days, but for maybe like 16 or 17% of that, they remove it in 1 week time. And they have the team that works on that local area, so that the comparison is not like that with the Google. So Google have that like millions of downloads and millions of point of interest, and everywhere in the world we use that one. So it's kind of a similar, but it's not the, like you can, the scale is not, we cannot compare that Google scale with OpenStreetMap.
Understood. Understood. So my next question. So when you started designing the fake location detection method, so what are the preliminary challenges you faced in that actually?
So the thing is that first problem is that I need to get a data that is 100% correct or accurate. So for that one, I need to do a lot of research on that. That from where I can get the data. That has, we used to, like that we call it truth tables. So truth labels on that one. So it's 100% accurate. And while I'm researching on that one, so we have a community, like we have like Peel region. So I go to a Peel region official website, and from where I downloaded a data set that is accurate. So from where I download, so first of all, the problem is that from where I can get that data that is 100% accurate. So I downloaded from officially open source website, and then I downloaded, it's a government website, and from there I downloaded that one. And it has like around 19 attributes in the data set. So I remove some of them. I keep around, I think, 13 of them that is useful in my research. And the other thing is that then I need to like populate with fake addresses as well. So for that one, like how to do that, so I have a faker API, so I use that one, and we combine that data together. In that one we have true values and we have false values as well. So we combine that data. And also the other problem that I will address when you we go through with the with the architecture of our like what I propose the architecture. So we need to clean the data as well, because sometimes in the data set we have missing values, we have duplicate values, the email address may be not formatted or something like that. So the to clean the data is very very important. And then I use an algorithm like MLP, multi-layer perspective algorithm. And other thing is also the data. Like you also asked me that question, that how you but don't take this kind of a data. So I use transformer model for that, because there is a model available, transformer model, that I use because we need to have a different kind of a data. Like we have a text data, we have a numeric data as well. So with that one, it's kind of a challenge. So these are the main challenges that I face when I'm doing that work.
Got it. So my next question was primarily dealing with the data. So when you said about the data, like you mentioned, you have numerical data and textual data, right?
Text data also, yes. So these are the different data types we have it. And for that one, we need, when we are comparing with our base models, so some of the base models don't have that kind of input data for that. So that in that way, there is a model called transformer model that I use to train that algorithm on that data set.
Okay. Okay. Cool. So yeah, so this is the framework which I got it from your paper actually. So you briefly described about some of these components. So what exactly comes in the pre-processing state, and what exactly you are trying to
Yeah,
do in
so
that data set?
yeah so the yeah so the thing is that if you look into that one, they have two basically components. One is called the data component, which has three sub components, and the other part is called the classified component. So the basically the data component is basically takes the POI data as input from the data storage and prepares the data for classification. That is the main purpose of data component that has three sub components. And the three components, or we call it data component, has three modules. The first one is called pre-processing modules. And the purpose of pre-processing modules like is to convert the raw data into a structured format. So the goal is to process and clean the data, detect missing values, handle imbalanced data, detect duplicate records, and the whole process transform the data into the format that is ready to be input into the proposed deep neural network based model. So that is the, like I told you before, that we need to clean the data. So the purpose of pre-processing module is to like if you say in one sentence, is to clean the data. The second one is very important, that is called a data labeling module. And like I also told you that we already get a Peel region data center from Government of Canada, and that is accurate. And these point of interest are updated regularly, and it's under an open data license. And the other thing that we do in the data labeling module, that we need to have a fake point of interest. So for that one, I use Faker API. So that is the purpose, so that the data has true values and the data also have some fake data labels as well. The third component that you can see, pre-processing, data labeling, and the last one that is in data component is called the, is basically third one and last one is data component, and is in that one is an MLP training module that basically prepares the data for training for the classifier model. So That is the main purpose of data component pre-processing. And then we have the data labeling module and the data component module. So then what happened that the data is passed to the classifier component. Now the classified component takes the label data as input with ground truth labels, and this component is basically consists of a deep neural network, and it is used to detect a point of interest as being true or false. And for that one, we are using MLP neural network, multi-layered prescription neural network in this module. And also we need to fit the model, and it also takes an input the test part that is basically used to evaluate the model. So that is basically the purpose. So if you see that one, we have data component here and we have classifier component. So at the end, we also use the test data to evaluate it. So at the end, we get the labels as fake or real. So we can justify that one, that in testing data we have that one, and our training data set is also doing predicting the same thing. So the algorithm is working very good.
Okay, so ideally it's more kind of like a binary classification problem in the end.
Yes, it's kind of a yes, yes,
Okay, which
yes,
takes both the input from text as well as
yes,
numeric. Okay.
yes,
Yeah.
yes, yes, that's
Okay,
correct.
got it. So yeah, so model details anyway you have mentioned. So on the output side, like we will get whether it is real or fake, comparing with the yeah.
Yes, we need to check that one whether we get the and also see that one whether this is actually a fake one, and it is predicted as fake. Whether it's a real one, it is predicted as real. So if you see that one, there is one terminology call it true 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 positive, true negative, negative negative, and true negative. So this kind of a thing I did that.
Okay, okay, got it. Okay. So, looking at the performance, like you said, you have benchmarked with some great models, and what were your observations?
Yes. We took four parameters for checking our model, like for accuracy, recall, precision, and F1 score. And we compare and we name that model as FDM, fake detection model. And we compared that one with many baseline models like BERT, Uncase, Case, Funnel Transformer, BART, Robert A, Knife Beast, SVM, Linear Kernel, LDA, so you name it. So we compared with many baseline models, and while comparing that one, that our accuracy is 94%. So none of that algorithm like baseline models have this kind of accuracy. Recall is also 97%, precision is also 94%, and F1 score is 95%. So we compared that one with all these baseline models, and our model accuracy, recall, precision is all around 94, 95. And the other models, like I also compared that one with other, like the best model. So for example, for precision it is 11% more than other any other precision that is calculated by any other baseline model. Same thing with accuracy. So it's not that overall it is best, it is also when we are comparing with other best, like for precision, which model has the best precision. For example, for this one, the best precision for best accuracy, you can say, is basically comes out to be 83%, that is knife base, and R comes at 94%. Recall is also the maximum that recall comes up is 82%, and R is 97%. So same thing with individually also, it is performing very well.
Got it, got it. Cool. So, yeah. So, what are the future scope for this particular project? Like, how you're gonna improve when it comes to like whether you'll be trying out new models or you'll be having a lot of new data. What will be the future scope?
Yes. So the main like the thing is that it's just a first work that I did on the fake. I have other papers as well, but this one is I'm looking into the fake and point of interest locations, and my interest developed in that one very much. So the thing is that now, because this data set that I work is a small data set, is not a very huge data set. So my future scope is that now I'm started working on Yelp dataset. So Yelp dataset is a very big dataset. So now I'm going to apply like I need to I'm going to fake free the Yelp data set. So I'm going to do that one. And also I'm going to have some expand our model to other deep neural networks or towards an ensemble approach where we can mix some models together and come up with some best approach. So because when we are applying, you know that when we apply some algorithms or some design or model on small data set, you can may get good results. But if that same model we apply on a bigger data set, then we have some problems, right? So maybe it cannot do the efficiency or accuracy is good, but precision is go low. So things like that. So for that one, I'm working on it, and hopefully, like my target is to do it in 1 month. So I'm still working because a lot of holidays, and so the thing is that now I'm working on it, and hopefully we'll do that one in this month, maybe, yeah, in January or February. Yeah,
That's really cool to know. So yeah, so thanks a lot
yeah,
for sharing this information about this particular problem.
no
It seems
problem,
pretty
anytime.
interesting, and yeah, so yeah, really looking forward to see your other contributions towards the open source community. And once again, thanking you for joining this particular podcast, Mr. Saeed, and thanks a lot for sharing all the
Thank you.
details about your research project. So
Yeah, thank you,
yep,
Deepak.
yep,
Thank you so much for inviting me. Thank you so much.
sure.